Hi, and welcome back. This is Chapter 8, Antennas. There is 76 questions in this chapter. Chapter 1. Which type of antenna would be a good choice of part of a portable HF amateur station that could be set up in case of an emergency? A dipole. Number 2. In a Yagi 3-element directional antenna, the blank is primary for mechanical purposes. Boom. Number 3. In a Yagi 3-element directional antenna, the blank is the longest radiating element. Reflector. In a Yagi 3-element directional antenna, the blank is the shortest radiating element. Director. Number 5. In a Yaegi 3-element directional antenna, the blank is not the longest nor the shortest radiating element. Driven element. Number 6. Why is a 5/8 wavelength vertical antenna better than a 1/4 length vertical antenna for VHF or UHF mobile operations? A 5/8 wavelength antenna has more gain. Number 7. What is an advantage of downward sloping radials on a ground plane antenna? It brings the feed point impedance to 50 ohms. Number 8. If a magnetic-based whip antenna is placed on the roof of a car, in what direction does it send out radio energy? It goes out equally well in all horizontal directions. Number 9. The main characteristic of a vertical antenna that it will receive signals equally from all compass points around it. Number 10. Why is loading coil often used with an HF mobile vertical antenna? To tune out capacitive reactance. Number 11. How many directional driven elements do most Yaegi antennas have? 1. Number 12. Number 12. Approximately how long is the driven element of a Yaegi antenna for 14.0 megahertz? 10.21 meters or 33 feet and 6 inches. Number 13. The delta loop antenna consists of 2 or more triangular structures mounted on a boom. The overall length of the driven element is approximately 1 wavelength. Number 14. Approximately how long is the director element of a Yaegi antenna for 21.1 megahertz? 6.4 meters or 21 feet. Number 15. How do you calculate the length in meters or feet of a 1/4 wavelength vertical antenna? Divide 71.5 or 234 by the antenna's operating frequency in megahertz. Number 16. What is the main reason why so many VHF base and mobile antennas are 5/8 of a wavelength? The angle of radiation is low. Number 17. If you made a 1/4 wavelength vertical antenna for 21.125 megahertz, how long would it be? 3.36 or 11 feet. Number 18. What happens to the feed point impedance of a ground plane antenna when its radials are changed from horizontal to downward sloping? It increases. Number 19. How long is the reflector element of a Yaegi antenna for 28.1 megahertz? 5.33 meters or 17.5 feet. Number 20. If you made a half wavelength vertical antenna for 223 megahertz, how long would it be? 64 centimeters or 25.2 inches. Number 21. What is one effect of increasing the boom length and adding directors to a Yaegi antenna? Gain increases. Number 22. Which of the following transmission lines will give the best match to the base of a quarter wave ground plane antenna? 50 ohms coax cable. Number 23. What does the term antenna front-to-back ratio mean in reference to a delta loop antenna? The power radiated in major radiation lobe compared to the power radiated in exactly the opposite direction. Number 24. What does antenna front-to-back ratio mean in reference to a Yaegi antenna? The power radiated in the major radiation lobe compared to the power radiated in exactly the opposite direction. Number 25. Approximately how long is each side of a cubicle quad antenna driven element for 14.3 MHz? 5.36 meters or 17.6 feet. Number 26. The spacing between the elements on a 3-element Yaegi antenna representing the best overall choice is blank of a wavelength. 0.2. Number 27. The impedance in ohms at the feed point of the dipole and folded dipole are respectively, 73 and 300. Number 28. Which statement about the 2-element delta loop and quad antenna is true? They compare favorably with the 3-element Yaegi. Number 29. Approximately, how long is each side of a cubicle quad antenna driven element for 21.4 MHz? 3.54 meters or 11.7 feet. Number 30. Approximately how long is each leg of a spherical delta loop antenna driven element for 28.7 MHz? 3.5 meters or 11.5 feet. Number 31. The cubicle quad or quad antenna consists of 2 or more square loops of wire. The driven element has approximately over all length of 1 wavelength. Number 32. Moving the feed point of a multi-element quad antenna from a side parallel to the ground to a side perpendicular to the ground will have what effect? It will change the antenna polarization from horizontal to vertical. Number 33. What is one disadvantage of a random wire antenna? You may experience RF feedback in your station. Number 34. What is a cubicle quad antenna? 2 or more parallel 4-sided wire loops, each approximately 1 electrical wavelength long. Number 35. If you were to cut a wavelength... Number 35. If you were to cut a half-wave dipole for 3.75 MHz, what would be its approximate length? 38 meters or 125 feet. Number 36. Why is a Yaegi antenna often used for radio communications in the 20-meter band? It helps reduce interference from other stations off to the side or behind. Number 37. Compared to a dipole antenna, what are the directional characteristics of a cubicle quad antenna? The quad has more directivity in both horizontal and vertical planes. Number 38. What is a disadvantage of using an antenna equipped with traps? It will radiate harmonics. Number 39. If you made a half-wavelength dipole antenna for 28.550 MHz, how long would it be? 5.08 meters or 16.62 feet. Number 40. What is a good way to get a maximum performance from a Yaegi antenna? Optimize the lengths and spacing of the elements. Number 41. What are some advantages of a Yaegi with wide element spacing? High gain, less critical tuning, and wider bandwidth. Number 42. What is an advantage of using a trap antenna? It may be used for multi-band operation. Number 43. How does a bandwidth of a folded dipole antenna compare with that of a simple dipole antenna? It is greater. Number 44. What is a delta loop antenna? A type of cubicle quad antenna except with triangular elements rather than square. Number 45. A dipole transmitting antenna placed so that the ends are pointing north-south radiates mostly to the east and to the west. Number 46. What is the low-angle radiation pattern of an ideal half-wavelength dipole HF antenna installed parallel to the Earth? It is a figure 8 perpendicular to the antenna. Number 47. If the forward gain of a 6-element Yaegi is about 10 dB, what would the gain of 2 of these antennas be if they were stacked? 13 dB. If an antenna is made longer, what happens to its resonant frequency? It decreases. Number 49. If an antenna is made shorter, what happens to its resonant frequency? It increases. Number 50. Adding a series inductance to antenna would decrease the resonant frequency. Number 51. The resonant frequency of an antenna may be increased by shortening the radiating element. Number 52. At the end of a suspended antenna wire, insulators are used. These act to limit the electrical length of the antenna. Number 53. To lower resonant frequency of an antenna, the operator should lengthen it. Number 54. One solution to multi-band operation with a shortened radiator is the trap dipole or the trap vertical. These traps are actually a coil and capacitor in parallel. Number 55. Polarization of an antenna is determined by the orientation of the electric field relative to the Earth's surface. Number 56. If a parasitic element slightly shorter than a horizontal dipole is placed parallel to the dipole 0.1 wavelength away from it and at the same height, what effect will this have on the antenna's radiation pattern? A major lobe will develop in the horizontal plane from the dipole towards the parasitic element. Number 57. If a parasitic element slightly longer than a horizontal dipole is placed parallel to the dipole 0.1 wavelength away from it, and at the same height, what will the effect have on this antenna's radiation pattern? A major lobe will develop in the horizontal plane from the parasitic element towards the dipole. Number 58. What is the antenna radiation pattern for an isotropic radiator? A sphere. Number 59. Approximately how much gain does a half-wave dipole have over an isotropic radiator? 2.1 dB. Number 60. How can a bandwidth of a parasitic beam antenna be increased? Use larger diameter elements. Number 61. What does horizontal wave polarization mean? The electric lines of force are parallel to the Earth's surface. Number 62. What does vertical wave polarization mean? The magnetic lines of force of a radio wave are perpendicular to the Earth's surface. Number 63. What electromagnetic wave polarization does a Yagi antenna have when its elements are parallel to the Earth's surface? Horizontal. Number 64. What electromagnetic wave polarization does a half-wavelength antenna have when it's perpendicular to the Earth's surface? Vertical. An isotropic and Number 65. An isotropic antenna is a hypothetical point source. Number 66. VHF signals from a mobile station using a vertical whip antenna will nominally best be receiving using a vertical ground plane antenna. Number 67. A dipole antenna will emit a vertically polarized wave if it is mounted vertically. Number 68. If an electromagnetic wave leaves an antenna vertically polarized, it will arrive at the receiving antenna by ground wave vertically polarized. Number 69. Compared with a horizontal antenna, a vertical antenna will receive a vertically polarized radio wave at a greater strength. Number 70. What is a parasitic beam antenna? An antenna where elements obtain their radio energy by induction or radiation from a driven element. Number 70. The property on an antenna which defines the range of frequencies to which it will respond is called its bandwidth. Number 72. What is meant by antenna gain? The numerical ratio relating to the radiated signal strength of an antenna to that of another antenna. Number 73. What is meant by antenna bandwidth? The frequency range over which the antenna may be expected to perform well. Number 74. In free space, what is the radiation characteristic of a half-wave dipole? Minimum radiation from the ends, maximum broadside. Number 75. The gain of an antenna, especially on VHF and above, is quoted in dBi. The I in this expression stands for isotropic. Number 76. The front-to-back ratio of a beam antenna is the ratio of the maximum forward power in the major lobe to the maximum backward power radiation.